Hi, this is a presentation on orthogonal contrasts. Orthogonal contrasts are otherwise known as independent contrasts. And one of the defining characteristics of them as well is that they are a priori or planned contrasts. Now, a good example in which to illustrate the idea of orthogonal contrast is the idea of a candy bar. So I'm going to draw a rectangle to represent a candy bar here. And let's say it's a Snickers, because I like Snickers. Let's say you come home from school and your mom says, oh, okay, I have a candy bar, but you and your sister have to share it. So you, let me get a different color, and your sister each get a piece. Hopefully they're roughly equivalent. You each get a piece, and now the candy bar has been cut. It can't be put back together. It's been cut. And then so your brother comes home and he says, well, I want a piece of candy bar. And you're like, oh, great. And so you end up having to give up one of your pieces. So your piece gets divided into two. So then your other brother comes home and he wants a piece too. So you end up dividing up, your sister ends up dividing up her piece of the candy bar into two. So it's you, your sister, then you, brother one, B sub one, and then sister, brother two. And you see how these contrasts are independent in the sense that there's no overlap, because after the piece of candy bar, the candy bar as a whole has been divided into pieces. You can't put it back together. You can't. That just doesn't happen. And it's the same thing with after you divide it by 2. So you can't put it back together. Now how we mathematically represent this, let me get over to, I have a little worksheet for you guys. A little worksheet for you guys here. On this worksheet, I've mathematically represented what happened in the candy bar scenario with the Snickers. So we have the first contrast, or C sub 1, right here. When you first come home and your mom has the candy bar and she says, oh, you have to divide it between you and your sister. And so we have the values of 1, 1, negative 1, negative 1. Then we have the second scenario where your first brother comes home and you end up having to divide up your Snickers bar, or your half of the Snickers bar into 2. So 1, negative 1. And then your other brother comes home in C3, third contrast, and your sister ends up having to give up a piece of her candy bar. So, but what are the rules that determine whether these contrasts are mathematically? So there's 2 rules. One is that the sum of the coefficients of each contrast is 0. This is represented by this column here. And then the sum of the products of the coefficients of each pair of contrasts is 0, represented by this row here. So let's first do the first rule. The sum of the coefficients for each contrast is 0. So if we add up these coefficients, 1 plus 1 is 2, and then negative 1 plus negative 1 is 2. So negative 2 plus positive 2 is 0. Looking good. The next contrast, 1 plus negative 1 is 0. Then plus 0 is 0. And then 1 plus negative 1 is 0. Then plus 0 is 0. Looking good. Now we have to do the sum of the products of coefficients. So you have to do the products of each combination of contrasts. So 1 times 1 is 1. 1 times 0 is 0. 1 times 0 is 0. Okay, so really you only have a value of 1 when you add those all up. So 1 times negative 1 is negative 1. Plus 0, then negative 0 multiplied by each is 0, so you have if you add that up, it is negative 1. Okay? Then you have negative 1 times 0 is 0, 1 times 0 is 0. So really all you have is -1 multiplied by 1 is -1. Next you have D, so you have -1 times -1 is positive, and of course 0 multiplied by each is 0. So if you add up the sum of the products of these coefficients, what do you get? You get -2 here, and then 1 plus 1 is 2, so you get 0. So these contrasts are indeed orthogonal. This has been a brief presentation on how to do orthogonal contrasts and how to check if they are truly orthogonal. Good luck and thanks.